of SCADA, then what is protocol, some of the old protocols that were used in the industry, then what were the limitations of those protocols, some of the IC protocols and some other famous protocols that were used, then the latest 61850 protocol, and then we will continue with the various aspects of 61850 protocol. So uh, to start with, I'll start with substation layout. So basically, when we talk about substation automation, so the layout of any substation becomes very important, because in substation, normally if it is an outdoor substation or a GIS substation, so we'll have some kind of switch yard. Now it may be indoor or outdoor. So if it is a air insulated switch yard substation, then the switch yard will be outdoor and it will be like covering a wide area. If it is a GIS, then also we'll have a switch yard, but again that will be gas insulated, so it will be little bit compact. Then we have some kind of auxiliary LV switchgear room, we'll have control room, we'll have DC battery rooms, we have communication room. It may be case to case basis, the communication room may be there, it may not be there. Then we have a control and protection room. So these are the main components of any of substations. I may be missing few other parts which are not that relevant, but majorly this is the part that is a component of any of the substation. Now, what is the need of automation if we talk about in power system or substation, or for what matters like anywhere? So basically, when we talk about automation, we want to get more efficient and more accurate, because more human involvement will be there in any operation or any monitoring, the more chances of error are there. And the more we make the things automated, it will become standardized and less cumbersome for anybody. So I have listed out some of the major things that automation can do better than us, is like better monitoring, faster control. Then as we know that in power system there are various dynamics is like there may be any kind of fault, overloading, under voltage, over voltage, high temperature of generator, high temperature of transformer, overfluxing. So there may be many challenges in power systems, and they pose a great challenge to the network or the system. So we need to take care of that, and we need to take action quickly. We need to work in milliseconds, microseconds. So that is humanly not possible. So we need intervention of the automation system in that. Then analytics, as we know that if there is any fault in our system, we need to find out that why is that fault that happened in our system, what is that fault, what is the nature of that fault, is it clear from my system, can it happen again? We need to do n number of analysis for that. So that also can be automated. Then again, as I already discussed, human error, safety. As we automate the system, it enhances the safety feature to a great extent, because being a human, we can again create errors, and that error will compromise with the safety. So we need to take care of that. Then repeatability and standardization, we already covered. Competition in the market. As you automate your system, you are becoming more efficient, and you are getting edge over your competitors in the market if you are in a competitive business. Then cost, by being more efficient, we can definitely save some cost. Then we'll be future ready. If we are upgrading our system, automating it with a smarter way, then we are ready to integrate with the future technology that is being coming into our system. So these are some of the needs that are there in power system. Now SCADA, what is SCADA? So the full form, as it says, supervisory control
Hello,
and
sir.
acquisition. Yeah.
Sorry to disturb you. Sir,
Yes.
please add some other students as well. You got the request?
Okay, wait. Yeah.
Please add them.
Okay. Uh, okay. Shall I continue?
Yes, sir.
Okay, fine. Okay. Then, yeah, we were talking about SCADA. So, concept of SCADA. What is SCADA? Basically, the thing we discussed earlier, automation or anything. So, SCADA is basically a tool through which we can achieve this automation. Now, as I discussed about the layout of substation, so there are various equipments in the switch yard, LV switchgear room, control room, CNP room, battery room. We have n numbers of equipments mounted in there, and in a central location, a control room which may be locally situated in the substation, or it may be remotely situated somewhere far away from the substation. So we need to get all the data of the switch yard, LV room, and all the portions of the substation to this control room. Now, how can we achieve that? So SCADA is one of the tool through which we can collect the field data. Like in this diagram, we can see there is a pressure switch, there is a flow switch, there is a level switch, there is a temperature detector. We are connecting it to some electronic device, and we are converting this analog signal to a digital signal. So basically, first step of any automation is to convert the analog field signal to digital signal, and then transmit it to any of the location. It may be locally situated, as I said, and it may be situated far away from your site. So if it is situated far away from site, then you need to take care of VSATs, fiber optic cables, cellular services, and you can send it on internet also. So you can connect it through wire or wireless mode and communicate it to a remote location. So first thing that you achieve through SCADA is you get all the signal, like if this switch is on or off, this water level is high or low, this temperature is above my set value or below my set value. So you can get all these status sitting in a air conditioned room far away from this location, and you can monitor all these signals through this process of SCADA. And also, since it has a word called control in it, so you can supervise it and you can control it also. So from a click of your mouse, you can switch off this pressure switch, or you can switch off this flow switch. So through that way you can control it sitting from a remote location. So SCADA is a tool through which we can achieve automation. Now, concept of communication protocol. What is a protocol? So first of all, we discussed about the layout. Then second is how we are transmitting the signal from location A to location B by converting it to a digital form. Then how we are achieving this conversion, this is the main thing. So that is done through some of the communication protocols. So what is protocol? First of all, you must have heard this term, because like whenever some business leader visits some other country, then we hear many times that the protocol was this but it was breached, and then the protocol was not followed. So what is protocol? Basically, protocol is some set of rules which are defined for any purpose. Like for a foreign visit internationally, there are various protocols defined, various rules defined. If a prime minister goes from country 1 to country 2, then the prime minister or XYZ minister of that country must come to the airport to visit and see him. So like that, that is a rule. So for communication also, we need to have some kind of rules. So that rule is called protocol. So in protocol, we define that how we will map the signal of the field that we are receiving through n numbers of wiring or XYZ things, and then we send it through a particular protocol. Now, what are various type of substation protocols that are used in substation? Like Modbus is very famous protocol. Then when we talk about IEC, then IEC 103, DNP3, Profibus, Spabus, Courier. Then we have 61850, 101. So there are n number of protocols which are there in the market, and they all have some kind of pros and cons. So we will discuss one by one. First of all, about some of the old protocols, and 61850, which is the latest protocol, which is quite popular nowadays in substation. So now I'll discuss little bit about how we collect the data and how it was collected in the old automation system. So as I told you that there is some equipment in the field. So like suppose this is a panel in my field, this is a protection panel, then this is a switch gear panel in my field. Okay, so what earlier we used to do, first of all the signals of these panels were wired to a device that was called RTU, remote terminal unit. So in this remote terminal unit, what we used to do, that we used to wire all the signals, and this remote terminal unit was equipped with some of the communication protocols, and it used to convert that wired signal into a soft signal. So I'll take help of a paintbrush to explain this concept a little bit. So like suppose there is a panel, and in this there is a circuit breaker or any switch, suppose isolator. So in RTU, what we used to have some kind of gateway. I'll explain what is gateway. And we used to have some cards. So there were some DI cards, digital input cards, some DO cards, digital output cards. There were some power supplies. Then there were some network interface cards. So all these cards were mounted. So what we used to do, we take the positive supply from the RTU to my device and bring it back to my DI card, digital input card. Now, when this switch will close, the digital output card will get a voltage, and this voltage will be converted from, like suppose this is a 48 volt or a 24 volt card. So that 24 volt, when it will receive, it will convert it to signal 1 binary, and when this is 0 volt, then it will be 0. So I am converting this voltage into a digital form, 0 or 1 binary, and this was connected to the gateway through some bus wires, communication wires. So here I have option that when the binary input card input 1 is high, then I can put a address in front of it based on the protocol. So like suppose I have an decimal addressing system. So the address may be 1000. So now this input is now 1000 for me, address number 1000. Again, if I have another switch, I will have another address 1001. So for this switch, the number is 1000. For another switch, number may be 1001. So when 1000 address is high, that means my switch, this switch is closed. So I, first of all, I converted voltage into digital, then I converted it into a address. Now again, this address can be converted to some other address, and that address may be suppose 5000 or AAA. Depending on the protocol, the type of address will be defined. Like suppose it is AAA, so I can do match the column. This 1000 will be matched to AAA for that particular protocol. So first of all, I converted voltage to digital, then I converted digital to 1000 address for protocol X, and for any another protocol which may be in any other device, like suppose there is a big HMI screen. So maybe this HMI supports any software protocol, XY protocol suppose. So it will support addressing system AAA suppose, and this RTU was supporting addressing system 1000, like this digital. So I wired connected this to 1000, and then I again connected this to AAA. So first of all, this is coming to 1000, then going to AAA. So HMI will come to know that this breaker is in on condition, and it will change the graphic in its monitor. So it's like that. So uh, yeah. So first of all, we wired it through copper wire to the IO card of the RTU. Then in RTU, we converted it to some digital form in protocol X. Then based on the address, we done match the column in this RTU software itself to protocol Y. And this device understands protocol Y. But this RTU can understand both X and Y. So first of all, it got X, it converted to Y. If there is any another device which understands X, so it will reflect the same X address to that device. So it's like that. So as I told that there are some protocols like Modbus, DNP3, 103, and this is same thing that I discussed. So the solutions were a little bit costly earlier, and lots of wiring was involved, because see, this switchgear may be located 500 meters away from the RTU, so you have to run 500 meters of wire for all the switches up to RTU. So this involved quite a bit of wiring in it. And also the chances of like modification was very difficult if you miss something. So it's very difficult to do the modification later on. So this was about the old protocol. Now here are some of the pros of these old protocols. 101 and 104, these are the protocols, these are IC protocols, and we still use these protocols to communicate with the remote substations. Like you must have heard about in India, we call load dispatch centers or grid controller. Then in every country, you will find some central control center of the power grids of that country. So normally they want the data, the status of the breaker, the current, voltage, frequency of different grids, the major grid substation of the country at a central location. So normally what we do, like if we were talking about any country, so there may be suppose this is substation number 1, 2, 3, and this is a central control center. So this is 1, 2, 3. So inside the substation we may have some other communication software working for control, but we connect a RTU or a gateway which converts this protocol to 101 protocol or 104 protocol. So what it does, because the central control center understand these protocols only, so the RTU or gateway converts it into 104 or 101 protocol and sends the data, maybe wireless, maybe wired, as I said in the SCADA slide earlier, that it may be wired or maybe wireless. So uh, we send the data through any protocol which it supports, the central control center, and it receives the status of the measurement, the equipments of these substation at this central location, and it can monitor and guide these substation, or in many cases control these substations also centrally, and can like save the power system for collapsing and any further damage. Okay, so
Hello,
one,
sir.
yes, yes,
Sir, please accept the request of everyone
yeah, yeah, sure,
who requested. Please check
yeah,
it continuously.
yeah, sure, okay, sure. Okay, so so 101 and 104 were the protocols used for remote control, and these were mostly the Ethernet protocols, and they worked on the transport layer. So if you have heard about the OSI network, OSI layers, so this is something related to that. Now 103, IC 103 is a very popular protocol. Before IC 61850, IC 103 protocol was used in substations, and it has very good range of like data transfer, and it is very simple to use. But it can be used only within substations, not outside substation. Now DNP3 is also a very popular protocol, and it is also used sometimes for the remote communications, but nowadays it's not very popular. But it's like faster as compared to 104 protocols, because it sends higher number of small data bytes compared to 104. Small in 104 we get slower data but with big data packets. So that's the basic pros of the some old protocols. Now these are some of the limitations of the old protocols that forced us to go to some new protocol options in the market. Okay, so first of all, most of the protocols were not like accepted by all the countries or all the manufacturers. Many of them were the proprietary protocol. What is proprietary protocol? Proprietary protocol is a protocol which is related to any particular vendor. Like suppose you talk about Hitachi, you talk about Siemens, you talk about Schneider. So if Schneider is having a X protocol, that cannot be used on Siemens relay. You cannot use that protocol for Siemens relay, or you cannot use that protocol for a GE relay. So they were not accepted everywhere. Then various ways of addressing. Now as I told you that we need to address these data that we receive on our input coils from the field. So all the protocols have different rules for addressing. Like you can see here, sorry, you can see here I have put a screenshot how we define or address in Modbus protocol. And I have also I have also mentioned how we do it for 103. So in 103, you have to define function type, info number. So this function type and info number for same data, like I am talking about overcurrent protection. It's a very simple protection used in most of the relay. So for overcurrent protection, there may be an address associated with that, which will be sent to the RTU or remote control center. But the address for Siemens relay may be 11. For ABB, it may be 1000, 10,000. For Schneider, it may be 5,000, 2,000. And also, it's a numeric value. So you cannot understand that it is a overcurrent element. If suppose I tell you 5,000, 1,000, can you relate it in any way that it is a overcurrent element? No, because until unless you don't have a file provided by the OEM, or you read it from the download it from the relay itself, till then you cannot understand that it is a overcurrent element. So these addresses were very vague and very user defined, varying from make to make. Same was the case with Modbus protocol was a bit more challenging because it was hexadecimal addressing. So it may be AAAA, FFFF, so ABCD, something like that. So if I say that for Siemens relay, overcurrent element address may be AFGH. So you cannot say that AFGH is a overcurrent element. You can't understand if I tell you only AFGH. So these addressing were very specific, and you need to have some support document to understand the relevance of these addresses. Also, uh, if you see, uh, the addressing were different. Than hardware port, to communicate with these protocols, hardware port is also very important, because you are converting the analog signal or field signal to a digital form. Now the digital signal will go through some kind of media. If it is a hardwire or it may be a wireless, so it needs some kind of media to travel from location A to the control center. So normally in old legacy protocols, the hardware was not standardized. Like you saw earlier, there were mobile phones. So some were having pin type of charger, some were having mini USB charger, some were having type C charger, blah blah. So XYZ different types of charger were there. But now even in the laptops or mobile phone, you will get a mini USB charger. So or type C charger. So it's standardized. So it helps you. You can plug into any charger if like suppose your friend is having a charger, you can borrow it and you can charge your mobile. So it's like that with the protocols also. Suppose I have same type of connector for all the devices, so it becomes very easy. If I'm in substation, any of the cable is faulty and I want to change it, so I can plug it out from any of the like less useful device, and I can plug it back to a more useful device. So the hardware protocols in legacy in legacy protocols, the hardwares were very different. Like I have listed out some. This is a RJ45 port, a LAN port. So it's a 9-pin port, and it was also used for 103 Modbus also. This is a DB9 port. This is again a 9-pin port. So it was also used for communicating with Modbus 103, any protocol you say. Now again, this is a terminal type connector, and there were fiber connectors also. So there was wide range of connector which was available, hardware which was available. It was not standardized. So this was also one of the limitations in old protocols or languages. Then data transfer speeds were also very limited because they were mostly using RS-232 or RS-485 type of communication. So these are serial communications. So in serial communications, we work on very little 12 volt, 5 volts of supply. So it becomes very difficult to carry it over longer distance. So if you carry it over a longer distance, you have to have some kind of repeater, or you need to break it and then convert it using some device. So it was very difficult, and also data loss was huge, and they were connected in series, in like parallel loops. So if loop breaks down, you will face like the data gets breakdown, or communication breaks down for the whole chain. So so it was like not a complete solution also, because it was covering either we are monitoring some base, either you are monitoring metering, either you are monitoring the battery health. So it was like that. So this is little bit about the Modbus protocol. Modbus protocol was again, earlier it was serial protocol, but nowadays you can find it on Ethernet also. Modbus over TCP/IP we call it. So it is IP based, and it is much faster and much mm, efficient to use. Why Modbus protocol I am discussing? Because still there are most of the metering devices or third party devices, like if you talk about the automatic voltage regulator, automatic tap controller, these kind of devices, cable monitoring systems. So these kind of auxiliary devices, fire protection system, they still provide the digital signal into Modbus protocol. So Modbus protocol is again a language which is understood by the different automation gateways. So it was earlier serial, now it's TCP/IP. Then it was having hexadecimal type of addressing system, and it is limited again to substation level. Okay, so now we will start with the major topic, that is IEC 61850. So we already discussed what were the like some of the limitations of the earlier protocols, and apart from that, I'll also throw some light on one of the major limitation that was with the old protocols that has been solved by the new IEC 61850. Like since most of you must be from some kind of industry, so like suppose we have in substation different forms of like different type of relays mounted. Suppose this is a relay 1, and this is
Hello, sir.
yes, yes ma'am.
Sir, please accept the request.
Yeah, sure.
Some people
But
requested
I
you.
accepted it. Right now no one is pending.
Please check it continuously.
Yeah, yeah, sure, I'm checking it. Sure, sure.
All right.
Okay. Yeah, right now there is no request pending, I guess. Okay, I'll keep on checking. Fine. Okay. So yeah. So like suppose we have four relays mounted in you have four relays mounted in your substation, and you have one RTU. RTU. So what was the structure earlier? That, like, suppose this relay is mounted on a line panel, line number 1. This relay is mounted on line number 2. This is transformer 1. This is transformer 2. Now I want to send this switch status of this line 1, line 2, transformer 1, transformer 2 to a control center. This is my control center located locally in my substation itself. So how we used to do earlier? We used to wire it into relay in the legacy protocol, wire it into the relay. Now this relay is located where? In my, again, control and protection room. This is CNP room. Okay, and these switches are where? In my switch yard. So this is my switch yard. Now the distance from control room to switch yard may be, suppose, 200 meters. So you are wiring this status from the field to the relay